All right, welcome back, everybody. Thanks for tuning in again. Today we are learning about reflections. Okay, so I would go ahead and label your title. We are on Unit 2, Lesson 3. We are learning about reflections. For math, reflections are a transformation in the coordinate plane that flips a figure over a line. So we are now flipping our figures over a fixed line, and it will still result in congruent figures. So don't forget, should be the same shape and the same size. Hopefully you have your sound on and you are buckled up and ready to go. You're going to need this foldable today. We're going to practice reflecting over the x-axis and the y-axis today. So we're going to complete this foldable together. Go ahead and open this. We're going to start with example 1. The figure shows triangle ABC. Graph the image after a reflection across the x-axis. So as always, when we are completing a transformation, we want to write down those original coordinates just to kind of keep us focused. So A is at 1, 3. B is at 5, 6. And C is at 6, 1, 2, 3, 4, 5, 6, 3. And we are reflecting across the x-axis. So don't forget about your x and y-axis. Your x is this way, your y is your up and down. So I like to draw a line over what I am flipping across to sort of remind me where I'm flipping. So I'm going across the x-axis. So what that means, I have to take this image, pretend that I'm folding the piece of paper right here, and that image is going to end up down at the bottom. So what we're going to do is we're going to start by counting. So right now, A is 1, 2, 3 units above my x-axis. So to reflect it, I'm going to flip it 1, 2, 3 units below my x-axis. Remember, I put my new letter and I put an apostrophe after it because that shows me that it's new. So A prime is now at 1, negative 3. I'm going to do the same thing with B. Right now, B is 6 units above my x-axis. I'm going to come down to my x-axis and count 6 units below. I'm going to put my dot. I'm going to make sure that I know which one it is. Write the letter, put the prime. Count my new units for B prime are 5, negative 6. And then our last one, C. C is currently 3 units above the x-axis. So I count 3 units below, put my new dot, put my C prime, connect my dots, and I have just reflected across the x-axis. Don't forget to put your C. Your C is now at 6, negative 3. Okay, so we're going to look for some patterns today as well. Our pattern for this first one, if I look, my x didn't change at all when I went across the x-axis. But my y, they all changed to the opposite. So where they were positive, they now are all negative. Well, let's see if that happens again in example 2. Okay, this time I have quadrilateral FGHJ, and we're going to graph the quadrilateral after a reflection across the x-axis. Again, since I'm going across the x-axis, I'm going to draw a line on my x-axis. Kind of lets me know where I'm trying to go across. And then I'm going to write down those original coordinates. F, G, H, J. Kind of a mouthful. F, G, H, J. 2, 3, 4. 1, 2, 3, 4, 5. F is at negative 4, 5. G is at 2, 5. H is at 1, 3. And J is at negative 3, 3. And again, we're going across that x-axis. Oops, I'm a little crooked. So we're going to again count. Doesn't matter which point you start with because you got to do it for all 4 of them. And we're going to see how far away we are. Notice my h is 3 units above. I have to make sure that it ends up 3 units below. Put my letter, put an apostrophe, that's my new unit. I'm going to do the same thing with G. Put my new dot, put my apostrophe. Again, I'm looking to make sure that it looks congruent. Should be the same size and the same shape when I'm finished. This one is J. And then my last one is F. And it's F prime when I graph it down here. Connect my dots. And if I look, I still have a trapezoid. So I'm going to put my new ordered pairs. Always got to have those down. F is now at -4, -5. G is at 2, -5. H is at 1, -3. And J is at -3, -3. So each time when I reflected across the x-axis, my x-coordinate stayed the exact same. But my y-coordinate changed to the opposite. So what I'm going to do on the front of my foldable is I'm going to write down that xy changes to x, the opposite of y. So although there's a negative sign here in front, don't forget that I'm doing the opposite of what my original y was. So if my y was originally a -5, the opposite of a -5 would be a +5. So I'm still doing the opposite no matter how it started. So that's my rule for my x-axis. Let's see what our rule is for the y-axis. I'm going to start with example 3 up here at the top. I have triangle XYZ and I'm graphing the triangle after reflection over the y-axis. First thing I want to do is write down my original coordinates. X is at -5, 0. Y is at -3, 5. And Z is at -2, 3. This time, since I'm going across the y-axis, I'm going to put a line right there. And then I'm going to flip my figure across that line. And remember, I'm just trying to figure out, well, if y is currently 3 units away from that line, and I flip across that line, it's going to be 3 units the other way. I'm going to have y, put an apostrophe, that's y prime. Remember that apostrophe tells me that it's my new point. Z is 2 units away, so I move it 2 the other way. Becomes Z prime, and X is going to move all the way out here. X prime. I connect my dots, and my 2 triangles should look the exact same because they are congruent. I'm going to go ahead and write my new ordered pairs. X prime, Y prime, Z prime. X is now at +5, 0. Y is now at +3, 5. And Z is now at +2, 3. So when I went across the y-axis, in my first one, all of my x-coordinates changed to the opposite. And my y-coordinates all stayed the same. Well, let's see if that happens in the last example that we have today. Now we have the figure shows quadrilateral MNPQ. Graph the image of the quadrilateral after a reflection across the y-axis. As always, start by writing down your original coordinates, MNPQ. M is at 1, -1. N is at 4, negative 1. P is at 6, negative 4. And Q is at 2, negative 6. Again, we're going across the y-axis. I always like to draw my line just so I don't forget where I'm flipping across. And then I start counting. M is 1 unit away, so it has to go 1 on the other way. And it becomes M prime. N is 4 units away, so it has to be 4 on the other way. Oops, I counted wrong. 1, 2, 3, 4. Precision is so important when you're doing these. P, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's P prime. And Q prime is 2 units away, so it remains 2 units away. You put your apostrophe, that's how we know it's the new shape. Connect your lines. You have a quadrilateral. 2 quadrilaterals should be congruent to each other. They should look the same, they just flipped over a fixed line. And then we put our new ordered pairs, M prime, N prime, P prime, and Q prime. M is now at negative 1, negative 1. N is at negative 4, negative 1. P, negative 6, negative 4. And Q prime is at negative 2, negative 6. So again, whoops, sorry about that. So again, when I flip across my y-axis, every single y-coordinate stayed the exact same. The only thing that changed was my x-coordinate changed to the opposite. So if it started as a positive, it changed to a negative. Started as a negative, it changed to a positive. So we're going to add that to the front. My original coordinate, xy, changed to the opposite of x, and my y stayed the same when I went across the y-axis. So it's kind of interesting that when I go across the x-axis, my x stays the same and my y changes. When I go across the y-axis, my y stays the same, but my x changes. And that is graphing reflections in the coordinate plane.